Hey guys, welcome back. Let's have a look over a new barometer and altimeter sensor that will be HP203B. And go on to the website that will be controleverything.com, and here on we have to search for HP203B, and let's see what we got here. And as you can see on my screen, it's a precision barometer and altimeter sensor. Also, some more features are represented onto the screen, and you can also purchase the sensor from this website. Furthermore, I will be interfacing the barometer and altimeter HP203B with a BeagleBone Black and C language code. And let's go to resource tab, and here we have the C code sample onto the screen. Now you can download the C code sample from this website as a zip file right from here, and also you can get the code from github.com, and the repository there will be Control Everything community. Now what we require is to make some hardware connections, and let's proceed. Well, for the hardware connection setup, the first thing we require is the BeagleBone Black, which you are able to see on my screen. And this here is an I2C Shield for the BeagleBone Black. Now this is available on the website controleverything.com, and the real reason we are using this shield is to make connections easier with other I2C devices. So for that, what we require is to gently place this I2C Shield over the BeagleBone Black and make a connection just like that. For the power up setup, we require two things. The first is a mini USB cable just like this and gently insert it over here. It is very useful to power up the BeagleBone Black. Now to power up the I2C Shield, we require a 5-volt adapter, which you are able to see on my screen, and gently insert it here. Now for an option for the internet connection, there are two mediums. The first is an Ethernet cable or a LAN cable, and the second is this, a wireless nano USB adapter. This here is our barometer and altimeter HP203B, and this here is a connecting cable. Now make the connection among the cable and the sensor, and make sure that the brown wire of the cable should be connected to the ground of the sensor, ground terminal, and similarly to the ground of I2C Shield. So we are done with the hardware connections. Now let's have a look over the code. Regarding the interfacing part, first of all we need to log into github.com, and here we have to search on for the repository that will be Control Everything community. After getting there, we have to look after the code or the sensor first of all, that will be HP203B, and here comes the C code which you can see on my screen. And first of all we need to pursue the instructions part, and here we have to set up the BeagleBone Black, and the instructions are on beaglebone.org. Let me open up for you the link, and as you can see we have several steps to be undertaken for the proper installation, and do it carefully. After getting this, we need to download or pull the code onto the BeagleBone Black, and this command. This command is for the compilation, and this will run or build the code. Please note it down. And after that, we have get back to the C code, and it's a .c extension file. And the first thing you notice that we have included some of the header files here. And in the void main function, we have to check whether the I2C device or bus is open or not, and the I2C bus is connected at the address that will be 0x76. Now coming to the sending command part, the writing command, as you can see we have to send OSR and channel setting command 0x44 or with 0x00, as you can see, and we are going to read 6 bytes of the data from the register 0x10, which will be temperature and pressure data. And here comes the conversion of the data. As you can see on my screen, we have used the formulas which were described in the data sheet for HP203B. Now we have to display the output data onto the screen, and it is the pressure in Pascal and temperature in Celsius and Fahrenheit scales. Now coming to the second part, we are going to send OSR channel setting command, as you can see 0x44 or with 0x01. And the command we are going to send is here. We have sleep function, and we are going to read, as you can see, 3 bytes of the data, the altitude data from the register 0x31. And here comes the conversion of the data. As you can see, we have this formula. We have seen this formula in the data sheet. At the very end of the code, we have the output data onto the screen, which is the altitude, and it is in the unit of meters. So this is how the code looks like. It's a very simple and generalized code. Now our next step is to look over the working part. Let's have a look over the working part, which is to check the practicality, which is very interesting in itself. And for that part, we need to copy the entire code and as you can see on my screen, the code has been copied. And then open up the terminal for the BeagleBone Black, and here we have to create a new file. As you can see, .c will be the extension, and for the reference we have placed the entire code here, and then we have to save it. Now for the compilation, this is the command, and let me tell you, the whole command is here, and this is the command for the compilation, and the code has been compiled successfully. Now for the working part, this is the command to run the code, and let's see what we got here. We have the pressure in Pascal, temperature in Celsius and Fahrenheit, and we have the altitude in meters. When I again run the command, you can see there is not a significant change, but when I try to press my finger over the sensor and run the command, you can see the pressure increases. We have the temperature in Celsius and Fahrenheit, which also changes, and we have the altitude, which changes reflected onto the screen. When I again run it, changes are onto the screen. It means the sensor is working as per we desire. It is as per we designed. Now let's see what are the applications and some of the features regarding the benefits of this sensor. The HP203B employs a MEMS pressure sensor with an I2C interface to provide accurate temperature, pressure or altitude data. The sensor pressure and temperature outputs are digitized by a high-resolution 24-bit ADC. The altitude value is calculated by a specific patented algorithm according to the pressure and temperature data. Data composition is integrated internally to save the effort of the external host MCU system. The applications are mobile altimeter barometer, smartphones, tablets, industrial pressure and temperature sensor system, weather station equipment, indoor navigation and map assist, GPS enhancement for emergency services, and a lot more. Well, you can have this sensor and you can purchase it from controleverything.com, and you can get the code from resource tab. From this site, you can download the code as zip file. Also, you can get the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubt regarding any part of this sensor or video, you can have your queries on controleverything.com, and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com, and to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.